Alright guys, how's it going? So I'm going to go ahead and go over chapter 126 with you guys. I know it's a little unorthodox doing it over video, but if you guys have any questions throughout, obviously write them down, and then on their group chat when I actually go live again, you guys can ask me all the questions. We're going to be learning about clutches today. Now, clutches, if you think about them, they are the basic blending point between the transmission and the engine. Okay, so this is where we can disengage and engage the transmission for when we're coming up to stops and when we're actually shifting gears. So first, let's go ahead and go over a little bit about what each portion or each part is. So first, we're going to start talking about the input shaft. The input shaft is the portion that's actually inside the transmission where we're going to be able to set up and have our clutch assembly attached to the crankshaft on the engine. Now, the parts working our way back, we're first going to talk about, after the input shaft, we're going to start talking about first the clutch fork. The clutch fork has the throw-up bearing or release bearing. There's the two different names, throw-up bearing or release bearing. This guy is attached to this. Now, this is the actual application side. Depending on what design you have hydraulic, and then you have cable or rod actuated clutch release mechanisms. This one, what happens is a rod comes in here. When you push the brake, when you push the clutch, it applies pressure, which then pushes on the release bearing, applying to your pressure plate. So the throw-up bearing goes right on the pressure plate like this. When you press onto the clutch, this portion here pushes on these little fingers. This is actually what is known as a diaphragm spring. This diaphragm spring is what provides the pressure for the clutch to engage on the clutch disc, which then this portion of the clutch disc applies to the flywheel. So we're going to go a little more over each one of these, but first let's just talk about the basic function of it. So when you step on the actual the clutch, the release fork pushes on the release bearing, which then pushes on the diaphragm spring, which then relieves pressure inside. The clutch disc itself, this portion here, is the only thing that's attached to the input shaft. So this is splined, and the input shaft has splines as well, which then grab it and basically provides the movement for the transmission. These two guys, the pressure plate and the flywheel, are attached to the engine. So these are mounted together. This guy is sandwiched in the middle. When you apply the clutch, it releases that pressure, allows the clutch plate to be spun separately from the actual engine itself. That's why you can actually push the clutch in and rev your car, because there's no more engagement with the transmission anymore. So, let me go on the next slide for you guys. When the clutch is released in the release position or clutch pedal depressed, the clutch fork is applying force to the throw-up bearing, this guy again, which pushes on the diaphragm spring, releasing the pressure on the friction disc. So now we're alleviating that pressure. We're not grabbing anymore. When the clutch is in the engaged position or clutch pedal up, the diaphragm spring exerts force on the clutch disc, holding it between the flywheel and the pressure plate. So everything is now being applied. Now everything's grabbing. They're all going to be spinning at the same RPM. The transmission has just been removed. Note, this type of transmission incorporates the belt housing, which was therefore removed at the same time as the transmission. The clutch fork and throw-up release bearing also came off together. All that remained attached to the engine was the flywheel, clutch disc, and pressure plate. So everything, this whole assembly minus the fork and the throw-up bearing are still on the engine. Some of these actually require you to separate you can separate the transmission from the throw. You slide it all the way out, the input shaft comes out. All of this actually stays inside the belt housing, which makes it kind of easier to do transmission swaps, because you don't have to take out all that stuff to actually pull the transmission out. You just pull 4 bolts, disconnect the drive shaft, and actually drop out the transmission. Alrighty. A typical cable operated clutch. So this release system utilizes an actual cable. When you step on the brake pedal, it actually pulls the cable, which then applies or releases the pressure off the plate. So this setup here is a little tougher to actually engage the clutch. If you've ever driven with a hydraulic clutch system or a mechanical one, you can totally feel the difference between the two, because one of them is going to have more force because it's actually your foot that's trying to release the pressure. When you use a master cylinder hydraulic design, you're actually using fluid to release the throw bearing, which then in a way that it actually helps with your foot actually not being so tired. If you've ever driven one with a mechanical linkage, you're definitely going to feel it burning in your thigh, because you're going to be stepping on the clutch a lot harder than it takes to step on the clutch with a hydraulic system. We have a master cylinder, we have a slave cylinder, and then the brake line in between. Just like any other brake design, like kind of like disc brakes or drum brakes, you have something that's going to provide pressure, you have something that actually exerts pressure out. So this way it actually is releasing the clutch fork, or applying the clutch fork, which then releases the pressure. Now, when you have a master cylinder, they are most likely going to be mounted somewhere along the firewall around the brake reservoir as well. Some of them share a reservoir, but it has a separate master cylinder that's usually by the firewall. The slave cylinder down here at the bottom is usually located on the bell housing. Just like Isaiah, your car actually has it on the, it's a combination throw bearing and a slave cylinder. So it actually will have a bearing just like this where it spins, but it also has a hydraulic, basically a plunger, that allows it to push out and release the pressure off the clutch disc. So here is the typical clutch master cylinder and reservoir mounted on the bulkhead on the driver's side of the vehicle. Brake fluid is used in the hydraulic system to operate the slave cylinder located in the bell housing. What happens if you actually lose, if you spring a leak and start leaking out all your brake fluid, you have no more brake fluid? That's right, you actually start to lose your clutch. Because you're not moving fluid anymore, you have air in the system, is going to cause either a spongy clutch pedal or no clutch pedal at all. A racing or high-performance clutch disc lacks the features of a stock clutch disc that help provide smooth engagement. When you start getting into performance, you're going to notice that a performance flywheel is going to have a more aggressive material used on the actual plate, the clutch disc itself. The reason why is most clutches provide some sort of slippage. It's to have a smooth transition from either takeoff to acceleration or from shifting from gear to gear. If you've ever seen a race car take off with a real aggressive clutch, you're actually going to have an issue with the car actually being a little more rough. So when it comes down to the actual material used, it's pretty much the same as brake pads. It's a little more sticky, you can say. It actually works better when it starts to get nice and hot. A typical stock clutch friction disc that uses coil spring torsional dampers. So it's actually at two portions. So these splines here sit on a separate section than the actual pad material. The reason why is it helps absorb shock. It actually causes it to grab and start to absorb it a little better. Rather than just sticking right away, it'll actually grab and then slowly start to engage to allow to absorb that extra energy, so you don't have too harsh of the actual takeoff. A Marcella is a wavy spring that is placed in between the two friction surfaces to cushion the clutch engagement. They're actually talking about, because this is a double-sided material, so you have just the clutch disc material here, clutch disc material here. Inside, in between, is actually what also helps with engagement, to have smooth engagement of each side of the actual clutch. Without this, it would be a lot harsher when you're actually taking off and when you're shifting into gears, or in between gears, sorry. Cutaway of the center section of a clutch plate showing the various layers of steel plates used in construction. So these are all the sections that I was talking to you guys about. It looks like it's all just one piece, but it's actually multiple layers stacked up together. A coil spring or lever style clutch pressure plate. So instead of using the diaphragm spring like I showed you guys on this flex plate here, we're actually using small springs that are surrounded all the way. So we actually have 9 springs total in this actual pressure plate, rather than just one giant spring that's actually cut up and then fused into the housing to allow that pressure and that tension. The upside to having this is you have a bit more force being able to be applied to it is usually for bigger vehicles. The diaphragm spring is a lot easier to assemble and for production, but the downside to it is you don't really have great or even spring application throughout. A typical diaphragm style pressure plate that uses a Belleville spring or diaphragm spring, because if you think about when we talked about brakes, you have that vacuum diaphragm in the booster, that diaphragm moves back and forth. The same way works with the Belleville or with a diaphragm spring. A flywheel flywheel has been machined or ground to provide the correct surface finish for the replacement clutch disc. Now, when it comes to your flywheel, flywheels are a key portion to the actual clutch operation. This is the first part that's going to be mounted to the crankshaft. So the crankshaft actually bolts directly to here and is going to have the friction material or the steel material where the clutch disc is going to first mate up. Now these are obviously the different clutch plates, but it's going to sit just like that, and then your pressure plate is going to be on the outside. Now the difference in between a factory flywheel, flex pace for automatic, is the weight on it. The reason why we have heavier flywheels for factory vehicles is because we want that smooth takeoff. If we have more mass and more rotational mass, the less likely it's just going to grab and it's going to start engaging right away. It allows for that slippage in between the clutch disc, the pressure plate, and the flywheel. So the starter motor will spin, but the engine will not crank if the ring gear on the flywheel is broken. One thing I did not mention yet is on the flywheel for pretty much all of standard or manual cars is we have these teeth coming along the outside. These teeth are there for starter engagement. This is how the vehicle is actually started. When you turn the key, it's going to engage the starter gear is going to pop out. It's going to mesh with these teeth on the outside of it, and then it's going to cause the engine to actually crank over. So without these teeth, you have no starter engagement, you have no start. So this can be an issue, but this one's showing that it's actually a single piece. These ones here are actually cut into the entire flywheel itself. Those ones are actually applied after the flywheel has been machined and has been set up for installation on the vehicle. A cutaway of a dual mass flywheel used on a Ford diesel pickup. Dual mass flywheels they're actually talking about basically the dual mass flywheel diesel pickup truck. So they're actually talking about, they have different sets of weight, basically for engagement through different RPMs and different loads. Because if you have a Ford truck like they're talking about carrying a lot of weight. This is actually to help progressively grab harder and harder instead of just engaging a giant clutch, which is going to be a lot harsher. It's to help ease into actually towing a lot of weight. Before replacing the clutch, the bell housing should be clean and the clutch fork pivot lightly lubricated. So I usually lube up the input shaft as well. It's always good to have a little bit of grease in there just to make sure that it goes in nice and smooth. And then the pivot fork, this section here is where this guy will actually sit. So it'll sit pretty much like that. And it's got the little groove in there. You can also just put grease in here if you're going to go ahead and just put the fork on. So just grease up the small little hole in here, or you can grease up the actual pivot itself. The input shaft seal should also be replaced to prevent possibility of getting transmission lubricant on the friction surfaces of the clutch. So they're talking about the actual transmission now. So we're going to set the clutch aside. There is a seal that the output shaft comes out of. If this seal is damaged, you're actually going to start to get fluid and bearing grease actually coming out, which then could actually contaminate the clutch disc and the friction material. The reason why that's bad is if you think about when you have a leaking axle seal, when we're talking about it in brakes, if you have a leaking axle seal, it'll actually cause the brakes to not function properly because now there's been oil contamination. It's going to be the same thing when it comes down to your clutch. You got to think of this almost like brakes, but instead of slowing something down, it's actually transferring energy to be able to accelerate. A transaxle assembly has been removed to replace the clutch. Note the short input shaft. This vehicle did not use a pilot bushing or bearing. So this is the design that Isaiah has in his car, It's actually going to be a combo unit. It's going to be the throw-out bearing, and it's also going to be the application force. So it's the slave cylinder / throw-out bearing. Now it's all one entire unit. It kind of looks like an accordion. It's got little ribs in it. It's actually almost looks like a valve. When you step on the clutch, it pushes it out, and when you release the clutch, it actually brings it back in. The clutch pedal linkage moves the clutch forward, which then applies a force against the release bearing, which then releases the clamping force the pressure plate is exerting on the clutch disc. So when you step on the clutch, it pushes here, pivots it, makes it move, and then pushes on the actual diaphragm spring, which then releases the pressure. I know I keep going over and over, but it's basically the only concept of actually how a clutch works. The release bearing rubs against the tips of the diaphragm spring, so you can actually see. You can see the shiny portions here. I don't know if I'm angling it right. These shiny portions here is where the actual throw-out bearing rests on. So as it rotates, it's pushing on that, and it's pretty much riding all the time unless when you release it, it backs off. When you step on the clutch, it grabs and starts to apply pressure, which then that means we're releasing the clutch. A release or throw-out bearing on a transmission that uses a clutch fork and mechanical or cable-operated linkage. So now we're talking either having rods that are connected from the pedal to the actual shift fork, or we're actually using cables. When we have the cables, it works its way around just like any type of linkage. When you step on the clutch, applies pressure, releases the clutch, the pressure on the actual clutch disc. A style of release bearing that includes the slave cylinder, sometimes called a concentric slave cylinder. Back to Isaiah's car, this is a little better picture. You can see we have the actual inside housing, the lines come out, they come out the side of the bell housing, and the brake lines connect in there, and when you step on the pedal, it pushes out the cylinder, and then when you release, it brings it back in. A combination release bearing and slave cylinder shown the two hydraulic lines. The lower line is the master clutch cylinder, and the upper line is used to bleed air from the hydraulic system. So you have the actual one that comes in. Now remember when we were talking about brakes, you want the bleeder at the highest point. That's why they put the bleeder above the actual line, because we want air to be able to escape up top. If the bleeder was at the bottom, then you actually have air in your system and you have a spongy pedal, which means you probably won't have proper clutch engagement, which means you probably won't be able to get it into gear. Now, when you bleed the system, it's just like bleeding brakes. You pump it a few times, you crack the line open, you close the line, pump it a few times, crack the line open. Just constantly, you keep doing it, but remember, it doesn't take as long as as if you were bleeding brakes. Using an abrasive disc to remove the glaze and to restore proper surface finish of the flywheel. Just like I told you guys, you got to think of them as brakes. We have mating surfaces here that need to be nice and smooth and clean. These ones are actually damaged due to too much heat and riding the clutch all the time. So we have to make sure that they're nice and machine finished, because if not, you can have clutch issues such as chatter. Chatter is actually basically the clutch plates, the clutch disc vibrating inside because of the engagement and the unevenness of both the pressure plate and the flywheel. A typical clutch kit, which includes the clutch disc, pressure plate, and release throw-out bearing, as well as the grease for the spline and the clutch disc engagement tool. When you buy an entire clutch kit, it's going to make your life so much more easier, because instead of just doing the clutch, you don't resurface the flywheel, now they get chatter, you're gonna have to pull that transmission back out again. In order to replace most clutches or all clutches, you have to pull the transmission. So why do everything 2, 3, 4 times? You can do it once and just replace everything. And then if there's a fault with one of these parts, guess what? The parts companies will give you the warranty pay, so you're still getting paid to do the job again, even though one of their parts is faulty. It's not through a fault on your own. A clutch alignment tool is inserted into the pilot bearing and over the splines of the clutch disc to keep the disc properly centered before installing the pressure plate. After the pressure plate has been installed and torqued to factory specifications, the alignment tool can be removed because the pressure plate spring force holds the friction disc tightly against the flywheel. This is probably the most important thing that I wanted to emphasize in this lecture. Making sure everything is aligned with each other is the key part to actually having the transmission go back in properly. When you have everything back together, so you have your flywheel on the engine, you have your clutch disc in the center, and then you have your pressure plate. When installing the pressure plate, it's going to start to put pressure on the clutch disc. when you start applying pressure to the clutch disc, you can't move this anymore. This can't be shifted around. So we have a tool with the same splines, and it's right here in the center. It has the same splines, it locks in, and then it pushes into the into the flywheel, and makes sure that it's centered with the engine. Then when you put the pressure plate on it, once you tighten everything down, now it's all fully engaged and tight. You can slide out that alignment pin, the pin. When you put the transmission in, everything's going to be perfect. It should slide right through. If there's any issues, then maybe something shifted along while you were tightening it, or you didn't have the tool in all the way. So just make sure when you guys are installing the clutch disc, before you throw it in, make sure everything's lined up before you lock it down. To check that the clutch properly installed before replacing all the components, try to turn the output shaft while the transmission is in gear and the clutch pedal depressed by an assistant. So once you're all done, everything's put back together, check and see, put it in first gear, push in the clutch, and see if the transmission still spins, or if it spins freely. If it spins freely, then the clutch is working properly. Tell them to let go of the clutch. If it engages, then you know that the clutch is working correctly. A typical cable-operated clutch adjustment location, the clutch can slip during acceleration if there is a lack of free play. The transmission may be difficult to shift into gear if there is too much free play. So, almost like having air in the system, or having an issue with, say, the slave cylinder. If you have too much free play, the clutch pedal can only travel so much. So if you have half of that is slack and then it starts to engage the clutch, you're going to be too far at the bottom to actually be able to fully disengage the clutch from the actual pressure, or to disengage the clutch from the clutch disc. So try to, some of them have adjustments so you can actually adjust free play to take it away, but you don't want it too tight where it's actually starting to engage the clutch itself before you even step on it. Making sense? All right, good. Any questions? Okay, good. Gravity bleeding and hydraulic clutch, opening the bleeder valve should allow air to escape and then fluid should flow. So just like I was telling you guys, just like bleeding a brake system, you pump it a few times, or you can even let it gravity bleed, but gravity bleeding obviously takes a little bit longer. So clutch placement 1. Now I'm just going to kind of breeze through this. They're showing you first that obviously we have to pull the transmission out. Now they're showing you you're going to actually take off the clutch disc. So now that the transmission's out of the way, you can see the setup here. This is the combo style throwout bearing / slave cylinder. So we're going to go ahead and unbolt the pressure plate first. Get the pressure plate out of the way, but when you take it off, remember that clutch disc is going to fall out. So he's grabbing onto the clutch disc and the pressure plate. So he's pulling out the, there is what is known as a pilot bearing. The pilot bearing is what supports the end of the actual output or input shaft of the transmission. Without that bearing, it's going to cause the transmission, the output shaft to do this, and you can damage the output shaft. So make sure that bearing or bushing is good. So that's what they're doing there. Now they're going to pull off the flywheel itself. So there's that bushing I was telling you guys about. You're actually going to grab it, and you can actually, some tools help you yank it out. Other ones are you have to actually destroy it to get it out, depending on how long it's actually been in there. Some of them are a real pain to get out. I've worked on ones that it took me like 3 hours to get it out, when it only took me an hour to pull the transmission out. So be mindful that you got to be patient, especially trying to get out the bushing or the bearing. The bushings are a little easier. The bearings are going to be the hardest because you have the small little needle bearings in the cage inside, and you have to break it all away, or if you try to pull it all at once, the entire thing just shreds and then you start throwing tools. So just be patient with it. You'll eventually get it out, or if you don't know how to do it, ask someone for help who's done one in the shop. So we have resurfaced the flywheel. So we're going to go ahead and mount it, put it back on. As you can see, they are using what? That's right, they are using a torque wrench. Because you want to make sure that this is evenly torqued down. It's just like cylinder heads, because if you get an uneven flywheel, you're going to start getting vibration, and that can not only damage the seal on the crankshaft right here, damage this seal because it's causing it to shake and move, but also you're going to feel the chatter when you're actually applying the clutch. So now they're installing a new bushing. So they installed a new bushing in. Now we're going to start aligning everything. We're going to put the alignment tool in with the clutch disc in there. So the clutch disc is inside. You put the pressure plate. You bolt it all back up, and then you go ahead and. Okay, so they have it all. I guess they're showing that it's all installed. Now you're going to bleed the system. Check for proper transmission shifting. So you're going to do a test drive. You know, just because you put everything back together doesn't mean that everything's correct. So make sure you go on a test drive, make sure it shifts smoothly through all the gears. Make sure, I'm sorry, let me go back a little bit. Make sure that it goes smoothly through all the gears. Now, when it comes down to test drive, you want to try to reenact and recreate pretty much any situation that a driver or a customer will go through. You know, stop and go traffic, accelerating hard, cruising, because you can actually come up and find a lot more other issues if, you know, something else is wrong. Now, for each one of these parts, a lot of these are going to be replaced when you do a clutch job. The clutch fork, unless it's damaged, you're not going to be replacing it. The throw bearing should be done every time you do a clutch. The reason why, this part is hard to get to. And if it's a bearing that, you know, if the clutch has 100,000 miles, this has 100,000 miles. So, you know, I always say is like, if you're already in there, you might as well do it. And going back to here, if you're pulling the transmission out, this seal here, it's also one of those things, you might as well replace it. The reason why is, if this seal starts to leak 1,000 miles down the road, they're going to think you did something wrong when you did the transmission. They're going to come back to you and say, why didn't you find it when it wasn't leaking? It's a $10 part. You don't add any additional time. You tell the customer, let's do your rear main seal while we're at it. And once you actually do, it's going to give the customer peace of mind knowing that that's already replaced, and it's going to give you guys peace of mind. The reason why is you won't have to do this again. You won't have to do it for, basically have the shop do it for free. And depending if you're hourly or if you're a flag rate, sometimes you're doing jobs for free because of something that you miscalculated or you just paid no attention to and didn't notify any of the service writers. So I think pretty much all of it is covered. If you guys do have any questions, please let me know. You obviously got the email and everything. Later on today, so I'm not even sure what time it is. Later on today, we're going to be on Instagram Live. So if you guys have any questions, try to watch it before I do my normal time. But other than that, you guys, I will get back to you guys on Instagram, all right? Have a good one, you guys.